Hi friends, here is a nice problem that has come in JEE Mains 2020. This is a very good problem. It tests our understanding, conceptual understanding of quadratic equations. Right, here we are given family of equations. Lambda square plus 1 into x square minus 4 lambda x plus 2 equals 0. Lambda can be anything. So if lambda can be 1, this will give rise to one equation. Lambda is 2, 3, 4, whatever. Right, there are family of equations. Now, what exactly this lambda can be? What is the range of this lambda? So that only one root lies between 0 and 1. Right. This is a system of quadratic equations. Right. They can have at max two roots. Right. Either both roots can lie between 0 and 1, or one of them can lie between 0 and 1, or none of them can lie between 0 and 1. Right. Only three possibilities. Both in this, or one of them in this, or none of them in this. Right. Now let us look at this little more carefully. This is lambda square plus 1. Lambda square is always positive, plus 1. So that means this part is always positive. Always positive. This is ax square. Right. A is always positive. And there is one this constant term constant 2. Right. So what does that mean? When x equals 0, when x equals 0, this set of family, this family of equations, they will pass through this point 0, 2 in y-axis through this point. When x is 0, whatever is the lambda, all the equations will have to pass through this point 0, comma 2. That is one thing that we have it is very clear here. What is the other thing? The other thing is lambda square plus 1 is always positive. What does that mean? This family of equations will be in the form of U-shaped parabolas, not inverted U-shapes. Right? Because this part is always 1, a square is always 1, this will always be like this. They will never be like this. Right? They will always be like this. These are these kind of parabolas. And all these parabolas, whatever are these parabolas, they'll always go through this point 2, 0, 2, always. So they can be like this, sorry. They can be like this, they can be like this, they can be like this, whatever. Right. Now, this is the understanding of this family of these parabolas. Now, let us then how do we find out what is this condition for one root in between 0 and 1? Okay, let's just look at this family of parabolas. Right, like we just discussed, all of this, they'll pass through this point 2. Right, I have drawn some sample parabolas when lambda equals 1. Then it is 2x square minus 4x plus 2. That is this line, this red one. When lambda equals minus 1, then it's the exact mirror image of this, the same red one. Right, red one, the same red one, minus 1 and plus 1. When lambda equals 2, then this becomes 2 square plus 1, 5x square minus 4 to 8, 8x plus 2. That is this blue line. Right, this will also pass through the same point too, just like we discussed. And when lambda equals minus 2, it is again the same blue line, just the mirror image. Right, when lambda equals 3, then this is a purple line, purple parabola. Same, when lambda equals minus 3, it is the same purple parabola on the other side. When it is minus 4, green on this side. When it is plus 4, green on this side. Like this. If you notice one thing, uh, all the minus ones and plus ones, basically it is minus 4x and plus 4x. This is basically minus 8x and plus 8x. Right, when lambda equals 2, it is 5x squared minus 8x plus 2. When lambda is minus 2, it will be 5x squared plus 8x plus 2. Right, only this term changes, minus 8x plus 8x, minus 12x plus 12x, minus 16x plus 16x. Then the graphs are just mirror images of one another. Why it is this? Please think about this. Why they are like mirror images? Or does it happen always? Or only these are special cases? Just think and write in the comments. Right. This is not related to the problem, but it's a good thing to think about this. Why they are mirror images. Now coming to the problem. Here, if you see, these are a family of equations. Right. Like we discussed. Then both roots can lie between 0 and 1. See, this is 0 and this is 1. Right. For example, for this green line, for this green parabola, both roots are lying between 0 and 1. Right. This one, right. This is one root and this is another root. Right. Both roots are lying. When for this green line. Similarly, none of the roots are lying between 0 and 1 for this red line because it is touching at 1. So not touching at 1 is not sufficient for us. It should be before 1. Right. One root should be before 1. This is one root on 1. Right. So there are these cases. For example, in this for this blue line, one root is here, one root is between 0 and 1, and another root is above 1, after 1. Right. We want this kind of blue lines. That is the question. Right. Now, how exactly do you find what is the range? If you notice, one point is always 2. Right. One point is always 2. Now, if one root has to lie between 0 and 1, right. Only one root has to lie between 0 and 1. If let's say what is the shape of this parabola? If the parabola, if the y coordinate of 1, f of 1 basically, if you put 1 here, f of 1, f of 0 is 2. If f of 1 is positive, is there any way that this parabola has a root between 0 and 1? It is not possible, right? If f of 1 is something positive, then the parabola will go like this, right? Or it can go little down also. It will go like this, right? It can go like this, it will go like this, or it can go even further down. But there is no way it will touch the x-axis somewhere before 1, right? That is very clear, right? If f of 1, if at 1, when x equals 1, if this equation is positive, if this equation is positive at when x equals 1, then there is no way this equation, this parabola is touching x-axis before 1, right? Because all kinds of 2 is we already discussed that the parabola will always be in the U shape. That means before 1, at 1 if it is positive, then there is no way where it will have one root. But so the graphs can be like this. Then when it is, because either the parabola can directly go like this, or it can go like this and like this. Right. In both cases, f of 1 is positive. But the problem in this case, if f of 1 is positive, that means there are two roots between 0 and 1. Right. This is one root and this is another root. In this case, if f of 1 is positive, that means there is no root between 0 and 1. Right. If f of 1 is positive, what does that mean? Either there are no roots between 0 and 1, or there are two roots between 0 and 1. So f of 1 cannot be positive. That means at 1, when x equals 1, this function cannot be positive. Right. Whereas when at x equals 1, if the function is negative, then there will definitely be one root between 0 and 1. Right. Because we have to connect this point 2 and whatever is this negative point. Then there will definitely be only one point between 0 and 1. The right, this whatever line we draw when y equals something negative, when x equals 1, right? Whatever is the point, whether it could be this point or this point, whatever is the point, when you are connecting this point and that point, this line will definitely cross x-axis, and it will cross only once, right? Then it will come outside like this, or it will still go down and come outside, whatever. Right. When x equals 1 and y is negative, right? When the value of this function is negative, right? Then there will definitely be only one root which is lying between 0 and 1. Please understand this. Why this function, why the function being positive at 1 will not help us. While the function being negative at 1 means this graph is going through the x-axis only once, right? And while coming back, it will come beyond 1, right? At 1, it is definitely negative, and at 0, it is definitely positive. That means there is one root definitely between 0 and 1, right? Now, what about the case when at 1, the function is 0, right? Then there are two possibilities. Either it can grow like this, right? It can go like this, like the red line. Then, then there is no root before 1. Or it can go like the purple line also. If you see the purple line, there is only one root between 0 and 1. But at 1, it is 0, right? So, f of x at 1, if it is negative, then definitely sure we have one root between 0 and 1. But if f of x and x equals 1 is 0, then also we have one possibility. What is that possibility? The possibility is this purple line, right? Only this possibility, right? There are no other possibilities. There is only one possibility when f of x equals 0 when x equals 1. Right. Now, let us use this condition and find out. So basically what we are saying, this f of x should always be less than 0 when x equals 1. That's what we are saying. Right. The graph can go somewhere down. It can go here, whatever. It can go here. But it cannot go above 1. So we are saying when if you substitute x equals 1, lambda square plus 1 minus 4 lambda plus 2 should always be less than 0. Equal to 0, we will take it up again. Less than 0. What does that mean? Lambda square minus 4 lambda plus 3. Right, 1 plus 2 is 3 is less than 0. That means lambda minus 1 into lambda minus 3 is less than 0. So lambda lying between 1 and 3. 1 and 3, this is definitely 1 and 3. If lambda is lying 1 and 8, definitely we can say there is only one root between 0 and 1. Because all the lines will be like blue lines. Lines like this. Lines like this. Like this blue lines. Right. As long as lambda is between 1 and 3. But we just discussed that when it is 3 or when this is equal to 0, when this is equal to 0, right, then also there is one case. What is that case? There is one case when this is equal to 0, right? When this function is equal to 0, there is one case. What is that case? The case is the purple case where it is going down and coming up and meeting 1 at this point. Then also it will still have one root between 0 and 1. Right. Now, when is this function equal to 0? We have only when lambda equals 1 or lambda equals 3. Okay. When lambda equals 1, then this equation becomes 2x square minus 4x plus 2, that is x square minus 2x plus 1, which we have discussed, x square minus 2x plus 1. Right. Then this equation basically means x minus 1 whole square, which is this, which is useless. When lambda equals 1, basically it is giving us this red line, this red parabola, which is not useful for us. When lambda equals 3, what will this become? This is 10x square minus 4th is 12x plus 2, right? Or if we simplify this, if we take 2 common, it will become 5x square minus 6x plus 1, which is equal to 5x square minus 5x minus x plus 1, which is x equals 1 by 5 or 1. So that is exactly this purple line. In this purple line, when lambda equals 3, it is having two roots. One is when x equals 1 by 5 and x equals 1, right? When lambda equals 3. When lambda equals 3, here we are having two roots, but then also only one root between 0 and 1, right? So we have to be careful here. One is when this expression is negative, sure shot. When this expression is negative, when f of 1 is negative, then definitely there is one root. But if f of 1 is 0 also, there exists this possibility that there is a root. There is this only one possibility, that is this purple line possibility, that there is only one root between 0 and 1. So that's why 3 has to be included, and at 1 it is not clearly not possible, right? So that's why the range of this lambda is 1 to 3. 1 is open bracket, 3 is closed bracket. We can include 3. Right, 3 is this, lambda is 3 is this line. We can include 3 for the range of this lambda, but we cannot include 1. Right, at 1 also, this equation is becoming 0. This equation is becoming 0, but that becoming 0 is useless because both roots are x equals 1. But at lambda equals 3, this equation is becoming 0, and this equation, when we make it 0, there are two roots. One is this root x equals 1, and here x equals 1 by 5. Right, yes. It's a beautiful problem. It tests our conceptual understanding of location of roots and how do we understand this family of parabolas. Right. It was given in JEE Mains, but it can actually be given in JEE Advanced also because the concept is very beautiful concept. Hope you like this. Right. Please comment if you have any issues. Thank you.